Hi, everyone. I hope you enjoyed the last two atmospheric tutorials. We are now going to switch gears a little bit and start talking about the ocean circulation and its role in climate. The first tutorial is going to involve the ocean wind-driven circulation. So as discussed in the previous tutorial and also in yesterday's tutorials, the ocean surface and the currents of the ocean surface are primarily driven by winds. In fact, this helps us explain a lot of the large-scale ocean circulation patterns as a result of the wind-driven and atmospheric circulation patterns. For today's tutorial, we are going to be using what's known as the ECHO model, which stands for Estimating the Circulation and Climate of the Ocean. Similar to the atmospheric reanalysis products used in the previous tutorials, this is an ocean reanalysis product, which involves a combination of an ocean model, the MIT GCM, and is also constrained by various observations, giving us a product that allows us to examine the physical processes in the ocean to help us better understand currents and also all sorts of different interactions and dynamics in the ocean system. So in the previous tutorial, we learned about large-scale atmospheric patterns and how the winds can exhibit different directions and different latitudes. These winds exhibit stress on the ocean surface, which leads to then ocean surface currents driving in a certain direction. Unintuitively, the ocean surface currents don't actually follow directly the atmospheric wind current, but rather the ocean currents end up at an angle relative to the wind at the surface. This is known as the Ekman Transport, which results in the ocean surface current being at an angle of about 45 degrees relative to the wind at the surface. We are going to be computing this relationship in today's tutorial, where we are going to be computing the wind stress at the ocean surface, followed by then the ocean surface currents relative to the wind. And you'll be getting into more details of this in the tutorial, but just as an example, we can see that these are not perfectly aligned. And in fact, there appears to be an angle of about 45 degrees between the ocean surface currents and the wind stress exhibited at the surface.